Question 3 was by far and away the hardest question in this learning quiz, and no one took the full 15 marks for this. So this is probably the one that most of you are going to want to go through. It starts off fairly easily. So we've got this person, Prachi, who is visiting the Grand Canyon and decides it would be sensible to throw some coins off the top. Essentially, both the sections in this question are on sequences. So we know that she throws a coin off the top of a cliff and it falls a distance of 5 meters during the first second, 15 meters during the second, and 25 meters during the third second. So to find the common difference, we just subtract any two consecutive numbers. So we can see here that the difference between these is plus 10, plus 10. So the common difference for this sequence is just 10. Write down the distance the coin falls during the fourth second. Well, that's straightforward. We know that the common difference now is plus 10, so we can find the next term, hopefully, which is going to be 35. So 2 really easy marks there. And even the next part, fairly straightforward. Calculate the distance the coin falls during the 15th second. So for this one, if we just remember the general formula for the nth term of a geometric sequence, which is in the formula booklet if you can't, but it's un equals u1 plus n minus 1 times d. And then substitute in what you've got. We're trying to find the distance the coin falls during the 15th second, so we don't know what that is, so we'll mark that u15 equals u1, the first term, which is obviously 5, plus n minus 1. Well, n is here. This is what we're interested in. So n minus 1 is going to be 14 times the common difference, which we found up here was 10. So that's going to be 5 plus 14 times 10, 140, which is going to be 145 overall. So 145 meters is going to be the answer. Right, part C then is where it started to get a little bit tricky for some of you. Calculate the total distance. The coin falls in the first 15 seconds. Give your answer in kilometers. So here the total distance is going to be the distance that fell during the first second and the second and the third second all the way up. So in effect here we are adding together all the terms in the sequence. So we're adding the series together and we're going to be using the different formula. What we're doing here is adding the whole arithmetic series. So the formula, well, there's 2 formulas that we can use. The simplest one is going to be Sn equals n over 2 u1 plus un. So we'll have to have a look if we can use that. Here we want to find the sum of the first 15 seconds. So n is going to be 15 over 2. u1 we've got, it's going to be the same up here, that's 5 meters. And if we're finding the sum of the first 15 terms, then we want this u15. Now we've just found out what that is. u15 is 145. So we can use this version of the formula, 5 plus 145. So that's going to give you 7.5 times 150. And if you work that out, you get 1,125 meters. However, you are not going to leave it there because for the final mark, it asks you to give your answer in kilometers. So you need to say either 1.125 kilometers, or if you want to give it to 3 significant figures, 1.13 kilometers. In part D, we were told that Prachi drops the coin from a height of 1,800 meters above the ground, and we're asked to calculate the time to the nearest second that the coin will take to reach the ground. Now, you might say, that's brilliant, we've just looked at the formula for that. So here we're trying to find, essentially we're trying to find n. We know that the total distance here would be 1,800 meters. The problem is we don't know n in this formula. We do know u1, but we don't know the distance the coin travels in the final second. So we've got 2 unknowns, so we can't use that easy version of the formula. We're going to have to use the more complicated version of the formula, which is Sn equals n over 2 2u1 plus n minus 1d, which is in the formula booklet. And again then, look at the information we've got. So we know the total distance it travels, it tells us here. So the total distance it travels is 1,800. We don't know what n is, that's what we're trying to find out. We do know what u1 is, that was the first number in the sequence, which we said was 5. So that's 2 times 5 plus, we don't know what n is, so we have to leave that like that. And d is 10, the common difference. So we can simplify that. We're going to end up with 1,800 is equal to n over 2. That's going to be plus 10. Well, let's just do it. So that's going to be 10 plus. If we expand that out, that's going to be plus 10n minus 10. So these, that plus 10 and minus 10 are going to cancel out. So we've got 1,800 equals n over 2 times 10n. If we multiply both sides by 2, we've got 3,600 equals n times 10n, which is going to be 10n squared. So n squared is going to be 360. So if we take the square root of that, we will end up with an answer of 18.97 seconds. So to the nearest second, that is going to be 19. For the final part, we're told that Prachi visits a tourist centre nearby, which opened at the start of 2015, and in the first year there were 17,000 visitors, which is expected to increase by 10% a year. So hopefully as soon as you start reading this question, you should be hearing alarm bells, because we're not increasing here by a fixed amount. In the previous question, we were increasing by a fixed amount, 10 meters every time. So that was an arithmetic sequence. Here we're increasing by a fixed percentage or ratio. So here we are looking at a geometric sequence. That's what we should be establishing first off. Right, so the question then, calculate the number of people expected to the tourist centre in 2016. So the common ratio here is 10%. So you need to increase this number, 17,000, by 10%. So multiply that by 1.1. And that should give you an answer of 1,870, which is fairly straightforward, 2 marks. For part F, it says calculate the total number of people expected to visit the tourist centre during the first 10 years since it's opened. So that is going to be the sum of the people in the first year plus the second year plus the third year. So this is a geometric sequence, and indeed, again, we've got the formula booklet to help us with this. So if we want the sum of the first 10 years, that is going to be u1 multiplied by the common ratio to the power n minus 1 all over r minus 1. So the first term u1 in this sequence is 17,000, so that's going to be 17,000, the first number, multiplied by r, which is the common ratio. So the common ratio here, if we're increasing by 10%, it's going to be 1.1. It's 10 years, so n is 10 minus 1 all over 1.1 minus 1. If we work that all out, you end up with an answer of 270,936 visitors, or 271,000, correct to 3 significant figures.